Welcome back to the Molar Express, and we are going to do a problem from page 9. It's a two-step problem. I don't think we've seen one of those, and it's going to be 3D. Let's see, calculate the following in molecules. Okay, so that's going to be our goal here, is to figure out molecules. I might just circle that here, and we're going to scroll down and find that. So our quest is to find molecules. And let's find this problem right here. Okay, and it is, I'm given 1.12 grams of K2CrO4. So let's just remember that piece from before. Our goal is to find how many molecules. And it looks like we're starting with grams, which isn't moles, which is a mass. So we got to go from mass all the way to molecules. And the only way to get there is to go from mass to moles and then moles to molecules. So it's going to be a couple-step process that we're going to need to follow. So I'm going to start by writing out what I know, which is my 1.12 grams. And it is K2CrO4. I've done, so if you go from grams to moles, which will be our next step, and maybe we'll write that down. So I'm going to times this by, and I think I'm going to go to a draw, and I'm going to put in a little line here. And I'm going to put grams on the bottom because that's where we're coming from. And I'm going to put moles on the top. Okay, so K2CrO4, we'd have to figure out the molar mass. Oh, wait, it's right here. So I can take that, and I only got 3 figures, so I can round that. I'm going to put 194 grams right here. And I'm going to put 1 mole here. So there are 194 grams in 1 mole. Notice whenever I do conversion from grams to moles, it's always 1 mole, and then the molar mass would go by the grams. Notice I'm coming from grams and going to moles, so grams goes on the bottom, moles goes on the top. So going from grams to moles, which would be kind of our midpoint right here, is dividing by the molar mass. So I take that 1.12 divided by 194, and then I get to moles. Okay, just a quick look. I did that molar mass for you, but I'll do a quick overview of that without doing the whole thing. So I would have to look up the molar mass of K, Cr, and O. I'll scan to a periodic table and just show where those numbers are. So K is down here. It's 39.098. I rounded that to 39.1. Cr is 51.988. So I rounded that to 52.0. And then the oxygen was 15.999. So I rounded that to 16.0. So I'm not taking the atomic number, I'm taking the mass with the decimals, and usually I kick them back to just 1 decimal place there. Okay, so that's what I did to get this molar mass that I'm working with. Okay, now the formula was K2CrO4, so that's why I multiplied K2 times its molar mass of 39.1. Cr, there was only 1 Cr in that, so I multiplied that by 1 times 52. And there's 4 oxygens, so I multiplied 4 times 16. I got the 78, the 52, and the 64. I took all of those things and added those up to get 194. That would be the mass of 1 mole of KCrO4. To convert 1.12 grams to moles, I would divide that 1.12 divided by 194, and then I get to moles. Okay, I'm halfway there. I don't necessarily have to calculate that. I can just show the rest of the string and calculate it all at once. So that's what I'm going to do. The next step, I'm going to draw a little line here. we'll put a times, and we'll put our line here, and we're coming from moles, and I'm going to put moles in the bottom, and then I'm going to put molecules on top. It's going to take a while to write. I might just type that in, and I'm going to write, it's a molecule. Technically, it's a formula unit because it's an ionic compound, but molecules is mine. Okay, I'll extend my line over. Now, the deal is there are 6 or 6.02 times 10 to the 23rd. Is it moles in a molecule or molecules in a mole? Again, it's always 1 mole here. So notice this conversion. It's going to be the 6.02. And I'm going to write that in here like this. 6.02, and I'm going to go E23. That E23 would mean times 10 to the 23rd. Okay, so if I say E23, that means times 10 to the 23rd. I'm just going to leave it like that. A little bit easier to type in. So what am I going to do? I just went from moles to molecules. And when I go from moles to molecules, I multiply by Avogadro's number, or 6.02 times 10 to the 23rd. All right, so ultimately I'm going to take 1.12 divided by 194, multiplied by 6.02 times 10 to the 23rd. And I think that equals, I had 3.48 times, and that would be 10. And I'm going to go E21, and that's going to be molecules. And I could say molecules of K2CrO4, but I think that that's going to be sufficient. Let's see if this answer makes sense. If I'm asked for an answer in molecules, and I have like 1.12 grams isn't a lot, but it's certainly a measurable amount, it's going to be, pretty big number. But because this is less than a mole, clearly 1.12 is less than 194, it's going to be less than 6 times 10 to the 23rd. It looks like it's a couple magnitudes less than that. So this looks like this answer makes sense. Okay, so just review, find your starting point. Just going to grab this here, which was mass, the 1.12 grams. Find your ending point, the molecules, which was written above. And then if it's a 2-step problem, if you're at mass and have to go to molecules, first you have to go from grams to moles. What did I do? I took my actual mass and divided by the molar mass. And then I go from moles to molecules, in this case, multiply by 6.02 times 10 to the 23rd. And then just make sure your answer makes sense. Hope this helps as you ride the mole train. Let me know the questions you have. Thanks.